On the ACT math test, logarithms commonly show up in one or two questions. For the most part, the ACT just tests basic knowledge of logarithms and doesn't go into great depth or great detail. Therefore, we're going to cover the basics in this video. So if you're not familiar with logarithms, a logarithm can be interpreted as, y is equal to log base a of x if and only if x is equal to a to the y power, where a is greater than 0. That's a lot of words. So basically what we're saying is, if we have a log with a base a of x, we should interpret that as a to what power equals x. So, for example, under here I'll write log base 2 of 8 equals, and we can interpret this as 2 to the what power equals 8. So 2 to the 3 power is equal to 8. So then this logarithm would be written correctly. So a couple notes here. So if we have the log of x, and there is no base given. So normally, we have a log base a of x, but in this case, we have no base given at all. So convention is, if no base is given, then the base is 10. So for example, log of x is equal to log base 10 of x. These are the same thing. Another type of special log shows up called the natural log, which we use the ln to symbolize. Natural log uses the irrational number e. So the natural log of x can really be interpreted as log base e of x. So those are just some basic things to know. Sometimes natural logs show up in the same way logs show up on the ACT. One other important thing for you to be aware of is the change of base formula. And what this means is, if you have a log base x of y, that can equal a log of any base, as long as that base is greater than 0, of y over the log of that same base of x. So log of y over log of x, as long as the base is the same. That is the change of base formula. This is important. Oftentimes the ACT will give you a logarithm and ask you for an equivalent logarithm. And a lot of the times they're just testing whether you know what the change of base formula is. Calculators are only programmed with log base 10 or with the natural log. So when you're doing a calculation and the base is not 10 or the base is not e, then knowing the change of base formula is going to get you the answer, because you can just plug into your calculator the log of y over the log of x when it's written in that form. So you can best solve that in a calculator using that logarithm button or that natural log button. So I'll write down a quick example here. So if we're given log base 3 of 12, and we want to round it to the nearest 100th place, we can type that in on our calculator as log 12 divided by log of 3. And that will automatically put in log base 10. And then that's going to give us 2.26. Let's finally talk about the properties of logarithms and some identities of logarithms. So this is going to be very similar to exponent properties, because logarithms are really just a case of exponents. So log base a of x times y, that can be rewritten as log base a of x plus log base a of y. What about log base a of x over y? Well, you'll probably guess this correctly, but log base a of x minus log base a of y. Okay, let's move on to log base a of x to the y. This one you may not know intuitively, but what you can do if you're getting a log of base a and x to a power, you can simply bring that power out in front. So this would be y times log base a of x. So now let's go with some identities. Let's take a to the power log base a of x. that simply is going to equal x. If we have log base a of a, well, that's just going to be 1. So we can interpret that, of course, a to the what power equals a? Well, a to the first power equals a. So that makes sense. And then we have log base a of 1. What's that? Well, if you think about it really quickly, a to the what power is equal to 1. So a to the 0 power is equal to 1. So again, logarithms are pretty much just like exponents. They actually can be considered exponents. So those are your properties and identities. I'm not going to go into detail proving these things or doing extensive examples. These are pretty self-explanatory. And when you come across logarithm problems on the ACT, they typically aren't going to be all that complicated. They just want to make sure that you understand the basics.